Hi, my name is Bobby Craig, and I am currently a third year statistics major here at Cal Poly. Today, I will be teaching a lesson that is following the blog of Professor Alan Rossman, which is called Ask Good Questions. Specifically, I will be looking at blog number 17, which is considering the random baby situation. So following this lesson, there will be two objectives that I want to accomplish by the end. The first will be understanding basic ideas of probability and randomness, specifically being able to determine and interpret probabilities from simple events. The second learning objective that we will be going over today is the use of simulation to estimate probability, and we will be doing this using the random babies activity, which is an applet that was created by Professor Rossman and Professor Chance here at Cal Poly. Okay, so here is the scenario. Imagine a hospital in which four mothers each just gave birth. But instead of the hospitals being able to correctly match each baby to the correct mother, they completely forget protocol. The babies all get mixed up and they end up having to deliver the babies to the mothers at random. And even though this is a complete hypothetical, it's just to get the point across. And so the question that is asked is, how many mothers end up with the correct child? And we know maybe that's zero, maybe they get lucky and all four are correct matches, maybe it's in between. We don't know that yet, but we are going to look at the probabilities for this question. Okay, so the question that we are going to have overlying this entire lesson is specifically the one above. It is arranging the following events from most to least likely. Event A, no babies are correctly matched. So this means that none of the four mothers get their correct baby when it's returned to them. Event B is looking at least one baby is correctly matched to the right mother. So this could mean all the babies are correctly returned, or even just one. As long as one baby is correctly returned to the mother, that is considered event B. And then event C looks at the probability that all babies are correctly matched. So this means that all four mothers get the correct baby back from the doctors. And so the question that I want to ask is, how can we find the answer for this problem? And there's multiple ways to do it, but the biggest one that we can do that's very simple, I'm going to go over on the next slide. And so one way that we can answer that current problem, determining what is the probability that a baby is returned correctly to one mother or all of them or none of them, is we can simulate that. And so traditionally in a classroom, I would ask you to draw pieces of paper, put the number 1, 2, 3, 4 on each of them, and then pick them. And then depending on which order you pick them in the number, that would determine what a correct match is. But because we can't do that, we can use an applet to simulate scenarios. And so what we do is we simulate, depending on how many trials we want. In this situation, we ended up doing 100, and we can see how many times one baby is matched, two babies is matched, three is, four is. And then looking right over on the right side is our frequency. So we can see that in this simulation of 100 trials, the most common response was there just being one match, followed by there being no matches, and then two matches, and then very unlikely to have all four matches, all four babies return to their mothers. And one question I want to ask you guys from this graph is, why are there no trials with three matches? And that may seem odd because the first thought may be, oh, well, three matches is less than four, so why aren't there more three matches than four? And the simple answer is it's impossible to have a trial with three matches. So this isn't just a simulation gone awry or just an outlier. It is physically impossible to have three matches and then one unmatched. And that's because if you were to have three correct matches, the only possible response for the fourth one would be the correct match. So that's why there's no matches no outcomes with three matches.